Good morning, guys. Today we're going to be talking about inverse functions. This is part one of a series of videos that we're going to do on inverse functions. And we're going to be able to find the inverse of functions algebraically and determine the inverse of relations and functions given as points or on a table. And so before we find the inverse relations and functions of points and tables, and before we find the inverse functions algebraically, let's define what an inverse function is. And in Algebra 1, you may have seen inverse operations, and we've been actually using them in the past couple of lessons when we're solving the quadratic equations. We've been doing inverse operations. Like when I ask you, what's the opposite of adding, what's the opposite of subtracting, what's the opposite of multiplying or dividing. So these are inverse operations. They're opposite to each other. And so if I ask what's the additive inverse of 3, what's the opposite of adding, it's subtracting. So for this example here, we would say the additive inverse of 3 is negative 3. For this other part, the multiplicative inverse of 6, what's the opposite of multiplying by 6? That's dividing by 6. So we can write it like that. Actually, let me fit it in the space here. It's 1 over 6. Okay. The next part is a definition of the inverse of a relation or function. An inverse undoes the particular relation or function. The inverse function for f of x is denoted by, so it kind of has this notation here, the f with a -1 and then a parentheses x. So these two symbols look the same, or look similar, but one of them represents the original function, and if it has a -1 as an exponent, that means that it's the inverse function. And we read this symbolic notation would be read f inverse of x. F inverse of x. Another thing about inverses is that the domain and the range of the inverse function is the opposite of the original function. So in other words, the domain of f of x is the range of the inverse, and vice versa. And we've seen this already in two functions that we looked at when we were doing transformations. When we were doing transformations, we dealt with the cubic and this is the cube root, right? And remember, we would use these tables to graph the parent functions. And like let's look at one set of points. If I look at these points and I compare them, do you notice that they are switched? They're flipped, right? If I'm looking at the cubic, my point is going to be -2, -8. But if I'm looking at the cube roots, then the x's and the y's switch, and it's going to be -8, -2. Oh, I wanted to put an arrow to say that these swap. They swap. And notice the notation here. We have the original function and the inverse. So we would say that the cubic function and the cube root are inverses of each other. Okay, so since we've seen, right, that functions can be represented in an equation. They can be represented in a table. And then you can graph these points to represent functions as a graph. So again, we can represent functions by points, tables, graphs, or even algebraically, like with equations. So we're going to approach each situation differently. And so the first thing we're going to look at is the first one that's listed here. We're going to look at inverse functions, how to deal with them if they're in a list or in a table. Okay. So this first part is, let me put both of them into view. Okay, so if we have an inverse function and it's in an ordered pair, we can get the inverse by swapping the x and the y values. So kind of like what I showed over here, that if I have an original set of points and I want to find the inverse of these points, then I just take each pair and swap them. I switch the order. So this is what this is saying right here. If I have an original set of points, if I have an original set of points, in order to get the inverse, I'm just going to switch the x and the y values. Okay, so let's put that into practice. Let's look at the examples here. And let me, I don't know why there's all this space over there, but let me zoom in here to example 1. Okay, so it says determine the inverse of each relation below. Okay, and so here we have 1, 2, 3, 4 points, and all these points have x's and y's, x's, y's, x, y, x, y, right? And so if I want to find the inverse, then I'm going to put like a similar notation of what they're writing here. So I'm going to do the curly bracket. And so this first point here, in order to get the inverse, I'm going to swap them. So instead of negative 3, 2, I'm going to put 2, negative 3, comma, go to the next pair, switch the order, 8, negative 1, comma, go to the next pair, switch the order, comma, and then the last pair, oh, I almost forgot to switch it, switch the order. Okay. And so these are my x's and my y's now, but these are switched over, right? Now they're inverses, right? And it says, is the original relation a function? So remember, the original one is the one that we started, the points that we started with. And so in order for a relation to be a function, we need to check one thing. So I'm going to write kind of a rule here. Functions do not have repeating x values. Okay, so functions do not have repeating x values. So let's look at the original points. if I look at all the x's, do they repeat? Do I have any repeats? -3, -1, 0, 9. Do they repeat? No. So we would say that this would be a yes. The next question says, is the inverse a function? So I'm going to look at all the x values and check to see if they repeat. Are there any x values that repeat? Yeah, I have a 2 and a 2 here. So the inverse is not a function, but the original is. Okay, so again, functions do not have repeating x's. All right, let's go to example 2. Let me slide down here. Okay, so this is my original, and over here I'm going to put my inverse points. Okay, how do I find the inverse points? Well, I'm going to do, or I can put the arrow over here and say that we're going to swap. Swap means to switch, right? So we're just going to switch the order of the numbers. So it's going to be 7, -4, -2, 3, 1, 1, and 6, 5. Okay, so it's asking here, is the original a function? So again, functions do, no, let me write it over here. Functions do not have repeating x values. Functions do not have repeating x values. So I'm going to look at the original x values, circle them so I can focus on them, and I'm going to check, are any of these repeating? No. So then we say, yes, this is a function. Let's look at the inverse. Check all the x values. Is this a function? Do any of the x values repeat? They do not repeat, right? So if they don't repeat, then they are a function. So I'm going to put yes. Oh, and I'm just going to put the color coding here. So again, the original points were a function because none of the x's repeat. The inverse is a function because none of the x's repeat. Okay. Now let's look at what do we do if I have an algebraic situation. And let me zoom out just to see what else is on the page. Okay. That's fine. Okay. So to find the inverse algebraically, follow the steps below. Change f of x to y. Swap the x and the y variables. Solve for y and replace y with f negative 1x. So these are steps that we're gonna follow, and I'm gonna try and kind of bring them up again. But if you want to have this page on a separate screen or something, or even as you're working on it, right, you can pause and kind of maybe take a picture of these steps so we can kind of remember them. But I'm going to be saying them as we're doing the examples. So again, we're going to change the f of x to a y. We're going to swap the x and the y variables. We're going to solve for y, and then replace y with this notation. So we're going to practice this 3 times and see if we kind of get the hang of it. So let me go over to the example. And let me zoom in as much as I can so that I know that I'll have space when I'm writing. Okay. So first step is, it says to change f of x, change this to y. All right. So let me write it out on the side here. I'm going to put step 1. Change f of x to y. So I'm going to circle it and do the step. So change f of x to y. Okay. Step 2. Switch x. My handwriting's off today. Switch x and y. So I'm going to circle the x and the y and put arrows to show me that I'm going to switch, and then I'm going to do the step. So if I switch it, it's going to be x equals 4y minus 20. Okay. Step 3. Solve for y. Solve for y. So I want to get y by itself. So what do I need to do? I need to move the 20, the negative 20. So what's the opposite of subtracting 20? Add 20. Okay, so on the left I get x plus 20 equals 4y, and negative 20 and 20 cancel out. Okay, again I want to solve for y, get y by itself. So let me box it again. I want to get y by itself, but I need to get rid of the 4. What's the opposite of multiplying by 4? Dividing. So this is going to cancel over here. And so I'm going to end up getting x over 4 plus 20 over 4 equals y. All right, and actually I needed more space, but let me just zoom out here and move it over here. See how it looks. Yeah, okay, it looks good. Okay, so just really quick, what I did here is, if I have a fraction like this, I can divide the 4 out into each part. So I'm dividing x by 4 plus 20 divided by 4. Okay, so I'm gonna simplify this. I'm just gonna put y equals x over 4 plus 5. Because what's 20 divided by 4? That's 5 over here. And actually there's one more step, step 4. So let's see, what does step 4 say to do? So step 4, I'll write it over here. It says replace y with f inverse x notation. So I'm going to circle what I'm going to replace. So replace y with f inverse of x equals x over 4 plus 5. That's my inverse. All right. Awesome. So again, let's look at the steps, what we did. So we started off with, then we changed f of x to y. In step 2, in red, we switched x and y. So if I switch them, I get x equals 4y minus 20. Then step 3 says solve for y. So this is what I want to solve for. So I added 20, then I divided by 4. And then step 4 says replace y with f inverse notation. Awesome. So let's try it again. And I feel like these steps are going to stay the more that we practice it. And I just want to make sure we get the steps down. Let's see, how do I want to write this? We already know it's example 4, so I'm just going to slide over so that I can write the steps on the right. Okay, so let's do the steps again. So step 1, change f of x to y. Okay, so this says change f of x, but we have g of x. So I'm just going to change just that small detail, because it's just saying, instead of f, we're naming the function g. So I'm going to say change g of x to y. Okay, so we're going to say y equals 1/2 x plus 1. Okay, step 2. Switch x and y. So that's going to give me x equals 1/2 y plus 1. Step 3. Solve for y. Get y by itself. So subtract 1, x minus 1 equals 1/2 y. What's the opposite of dividing by 2? Multiplying both sides by 2. So I'm going to get 2x minus 2 equals y. Because these two will cancel. And so I solved for y. And I'm actually going to write it, let me zoom out a little bit up here, but I'm going to write it with y first. So I'm going to write it like this. Okay, and then step 4, says replace y with f inverse, but I'm going to put g inverse of x. So I'm going to replace this with g inverse of x equals 2x minus 2. Okay, and let's do one more. All right. Step 1, change h of x to y. Change h of x to y, 2x minus 7 over 3. Then step 2 says switch x and y. Switch x and y. So I'm going to put, I don't want to make it that big. X equals 2y minus 7 over 3. Step 3, solve for y. Solve for this y. So opposite operations. Before I work with the 2 and the minus 7, I need to get rid of the 3. So what's the opposite of dividing by 3? Multiplying by 3, right? So I multiply 3 on both sides. I get 3x equals, these 3's will cancel, and I'm left with 2y minus 7. Then I gotta add 7 on both sides. That gives me 3x plus 7 equals 2y. The 7's cancel. And then the opposite of multiplying times 2 is dividing by 2. These will cancel. And so I'm going to get y equals 3x over 2 plus 7 over 2. And so I solved for y. So step 4, it says replace y with h inverse of x. And so notice, right, it started with h of x and it ends with h inverse of x. So let me zoom out here a little bit so it'll be in our window. And then I'm just going to replace y with h inverse of x equals, and then just copy. Done. Awesome. So that concludes the notes for today. If you have any questions, I can definitely go over those in class next time. Thank you for joining me today, and I'll see you guys next time in class.